Okay. They have a polynomial. Has they talked about how to get the first zero? Okay. So we're factoring large polynomials. Their example is x minus 3. Let's try that again. Okay. They have 3x squared minus 5x squared minus 7x minus 1. Alright, when you're dividing polynomials, essentially you're stuck with either 2, possibly 3 terms when you go to divide. Always look for the highest degree term. That's what's always going to be first. So our variable is to the degree of 1. We're always going to try to set that up to eliminate the first number, okay, in long division. So essentially I have to figure out what I need to multiply this by so that it becomes 3x squared, so that these will cancel out, and then I'll be left with some remainder down here when I subtract. Okay. So the idea is I need to turn x into 3x squared. So you know what I multiply by? Any idea? What could I multiply x by? So some number to get 3x squared.
Multiply it?
Yeah. A way you could do this is give this an actual variable. So let's say it's, we'll just call it another one, a. Okay. So this is our a term. You don't have to do this every time. This is just an idea. We need to find what a is. So we'll bring x over. So a is equal to 3x squared divided by x. And we'll simplify that. Okay. So a equals 3x. Does that make sense to you? When I simplify these two terms? Okay. So if I multiply 3x by x, so we write it in here, 3x, so I'm multiplying this term by all of this. So I multiply the first term by 3x and the second term by 3x. Okay. When I multiply x by 3x, I get 3x squared. When I multiply 3x by negative 3, I get negative 9x.
Period. Are there like a different way?
Another way you can think of it is this is the degree 1,
Okay.
so I clearly needed to get it to the second degree. So x times what would become x squared?
Well, I know that, like, she told us that up here, like, the degree is always going to be...
Alright, so yeah, so I wrote it down wrong. It's cubed. Okay, so 3x squared times x is 3x cubed. 3x squared times 3 is negative 9x squared. Does that make sense? Okay. Now in long division, whatever you have, you subtract. 3x cubed minus 3x cubed, these guys cancel each other out. Negative 5x squared minus 9x squared is
4, 5, 4, I don't know.
negative, oh, not 14.
Here, it's 5.
Oh, no, it is 14. Shouldn't it be? 14
I would use my calculator.
squared. Sorry. We have to subtract the terms.
Yeah.
So because we're subtracting the terms, it's like adding 9. So yeah, it's positive 4x squared. Okay. So now we have positive 4x squared. We're going to bring down the next term. Alright? Because essentially we're working with 2 terms, so we're always going to have to subtract by 2 terms. So I bring down the next term. Negative 7x.
Sorry.
Does that make sense?
Yeah.
So I brought that straight down.
Yeah.
Now I'm going to have to multiply again this first term by a number to create 4x squared.
Maybe 4.
Yep, 4 and then what? Because it's the degree 1. 4x. So we get positive 4x. So
You're multiplying not 4 by...
I'm multiplying this entire term
Yeah.
by this now. So each of the terms I have to multiply by 4x.
But to find that number, what do you multiply?
Oh yeah, to find that number, essentially
Right.
I kind of divided the x into this to find this number. Okay. So essentially I had 4x squared divided by x, 4x. Does that make sense? Kind of? Okay. We'll do a couple, don't worry. So when I multiply them, 4x squared times x, we get 4x squared. And 4x times negative 3 is negative 12x. Same idea, we subtract.
4 times like, okay, yeah.
Okay, these guys cancel each other out. And again, this is like negative 7 plus 12. So we end up with 5x. Okay? Bring down the last term, negative 1. So we still go back to this. And essentially, let's divide 5x by x. What does that become? 5. So that's a term I'm going to put up here. Okay. And essentially, I'm multiplying all of this, each of them by 5. So 5 times x gives me 5x. 5 times 3, negative 15. We subtract. These guys cancel. And we're left with plus 14. Okay? So when we go to write the whole term out, this is the important part. So say this is a function f at x. This is the first part of it. So x minus 3. The next part of the term is going to be up here. So what we divided to get, 3x squared plus 4x plus 5. So times 3x squared plus 4x plus 5. And then finally, remainder. Our remainder is plus 14. So we had 14. So this is the factor form of whatever it was to start. Did they give you? Oh, it was just a division question. So this is what it is after it's been divided.
What number is this?
Okay, so first of all, when you have to set up these, especially in long division, you always want the degree of the highest variable first. So essentially you set it up in order. Exponent 4, 3, 2, 1, 0. Okay? So we're going to be dividing by the bottom. So I'm going to set that up as x squared plus 2x plus 1, right? And the degrees of our functions right now, 2, power of 2, power of 1, and technically this could be x to the power of a 0. Okay? That's why it doesn't exist. Make sense? Okay. Then we go to set up the division, which I'm going to use a straight line for. It's better that way. Same idea. X to the power of 4 minus 2x cubed. Now, do we have an x squared in this? No.
So you have to add the
Yeah,
0.
I'm going to have to put in 0x squared. Okay. Then I have x to the power of 1, so plus 5x plus 3. So that's essentially what question A has. There is something missing in it. Okay, that's why you got a little confusion.
Oh, I didn't recognize that.
Yeah.
Stupid. I knew that too. I just didn't see it.
All right, do you want to walk me through this one? So what do you think I would do to start this?
Okay. The x squared.
Yeah, it needs to become
X.
so what would I have to
make that?
what would I multiply x squared by? So my a again to get to x to the power of 4. You can always set it up like that. That's a 4. Okay. Set it up the same way every time if you want on the side. I'm looking for a. That's what I'm going to put in here.
Wait, you multiply by x squared.
I got to multiply x squared because it's the first term, right? I got to make the first term the same as the first term inside the
So don't you
division.
multiply it by another x squared?
Yeah, exactly. Good. You got it. And if you were to do it over here, you just simplify x4, x2, power 2. A would have been x squared. So that's exactly what we needed to go by. Okay? So x squared. And now I've got to multiply x squared by all 3 of these terms. Okay? So x squared times x squared is x to the power of 4. X squared times 2x
2.
is positive 2x cubed. Okay? And x squared plus 1 is x squared. Okay? And here's where we do subtraction. These cancel out. This becomes negative 2x minus 2x cubed. Do you know what this is?
No.
Put in your calculator.
-4.
Good. And then 0 minus 1.
-1.
Good. Okay. Now I only have 2 terms. I gotta make sure it matches to these 3. So I'm going to bring down my next term. Okay. So I get plus 5x. Exact same idea as before. I need to get this term to become this.
Okay. So you multiply by -4x.
Yeah, negative 4x. Multiply by negative 4x. I'm going to get negative 4x cubed. That'll cancel out. Negative 4 times that becomes negative squared. And 4x times that is negative 4x. Subtract again. Goodbye. All right. All right.
On a test, I would just do it in my calculator to make sure.
Just to make sure. Okay. And finally, last step now. Same idea. We need to get x squared into 7x squared. What would I multiply by?
7.
Yeah. So multiply by 7. We get 7x squared plus 14x plus 7. We subtract. Goodbye. Negative 5x minus 4. Okay. So here's our remainder now.
Right.
Okay. So again, here's the first set of terms, second set of terms, and then I can't divide into it because this is a lower degree than our first degree. So when I go to set up the function, f at x is equal to, let me zoom out a bit so I can see everything. That's better. X squared plus 2x plus 1, x squared minus 4x plus 7 minus 5x minus 4. Third example is asking if this, x plus 2, is a factor of this. So in other words, for it to be a factor, yes, plus 2, we need to check the zeros.
Right.
We have to see if the 0 goes in. So actually the 0 for this function is,
Negative 2.
yeah, okay, great, so you got that. So, so using, this is synthetic division in this case, okay? So we have our negative 2, set this up. And the other thing, what we're going to do is I'm going to rearrange what we have up here so that's in 4, 3, 2, 1. Okay? So let's get rid of some of this and the brackets. We'll rearrange it. So the highest term of this is x to the power of 4 minus 2x to the power of 3. There's no power of 2, so plus 0x squared. Power of 1 is positive 13x and minus 6. Okay? So in other words, now what we do is we're going to write the coefficients of each of these terms out on top. Okay? So our first coefficient is 1. Our second one is negative 2, 0, 13, and negative 6. So essentially we've just put the coefficient straight down into the synthetic division. Okay? First thing we're going to do is we're going to move this straight down, the very first term. Okay? So just assume it's the first thing we go down. We get 1. What I'm going to do from there is I'm going to constantly multiply our term on the outside by whatever I get on the bottom, and then whatever that is, subtract as we go through. So negative 2 times 1 is negative 2. Okay? When we subtract, it's important to remember we're subtracting. Okay? Negative 2 by negative 2 is... Oh, sorry. No, I have that wrong. Sorry. We add these two terms. So negative 2 plus negative 2 is negative 4. Then we do negative 2 times negative 4. Yeah. We add 8 plus 0, we get 8. Negative 2.
Negative 16.
Yep. Negative 16. Add those together, we get 3. Yep. And negative 2 times 3? 0. So, as long as our final term is 0, then that means yes. Okay? That means yes, this is a factor. So in fact, what that means now is our factors.
Oh, so like if the remainder is 0.
Yeah, if the remainder is 0, then we know it's going to be a factor of it.
Right.
So we can factor this into x plus 2, and then in the rest of it, these are the coefficients now, each of these, of our next terms. Okay? So we factored out an x. So this is the coefficient of x cubed, we put a 1 there, minus 4x squared, plus 8x minus 3. So that's an even. Okay, so we got the long division, same idea. X to the power of 4 needs to become x to the power of 5. So what do I got to multiply by?
X.
Just x. Okay, so that's going to get us x to the power of 5 plus x to the power of 4 plus x to the power of 3 plus x to the power of 2 minus 2x. Does that make sense? So I did a great rainbow effect here.
Oh, okay.
That's what I did. Okay? So because the coefficients were all ones, all these coefficients were ones, and all that happened is I upped the degrees because I multiplied by x. And then the last one was negative 2x. Make sense? We subtract now. Goodbye. This becomes 4 minus 1, which is 3 power 4. Make sense?
Yep.
0 minus 1, negative 1x cubed. 0 minus 1, negative x. Or 1, sorry. And 9 minus negative 2 is positive 11x. Good?
Right, moving in the 8.
Sweet. And then we got to get 3x to the power 4 from x to the power 4. So what would I multiply by?
3.
Yeah. Multiply 3, so I get 3x power 4 plus 3x cubed plus 3x squared plus 3x minus x. Good? Sure? Okay. Goodbye. 1. This is essentially 1 subtract 3. So negative 4x cubed. 1 subtract 3 again. Negative 4x squared. 11 subtract 3. 8. And 8 plus 6. 14. Okay. I now have an exponent higher than this. So right where I can go. So I'm going to have this times this.
Minus 1.
Yeah, well, plus,
like,
but yeah, minus. So we get f at x is equal to x
It's a lot easier watching it today.
Yeah, just like it's easier watching professional sports.
Wait,
or anything
don't
like
you
that.
multiply that one by that one?
Yeah, I just changed the order. Multiplication, you can do whatever you like.
Okay.
In terms of, you can multiply in any order.
I
So
thought that order was okay.
it won't change anything. If you ever want to test it out. If you're ever on a math test, this is what I used to do constantly. I would forget rules, and I would just test rules. I'd be like, I wonder if this is a rule. And just make up your own quick question. And if you can prove it like more than twice, then it's probably going to work in math. Okay? So like, for instance, if you weren't sure, I'll give you an example. Because exactly what you're saying, like, well, can I do that in that order? Make it simpler, obviously. Don't just go straight to it. So say if I didn't know what, and I should have, if it was a multiplication question, well, I had 5 times 3, I know that's 15. What if I did 3 times 5? Yeah, 15. What if I did it with 2 and 5? I still end up with 10. So it probably doesn't matter which way. Right? Always try to make things simpler. Test rules if you're not sure. Okay?
Yeah.
Does that make sense?